IBM 5160 XTs generally don't have problems with leaky batteries. Unlike the many clones that came later, the 5160 didn't have a real-time clock and didn't need a battery. This IBM, however, seems to be an exception. Let me show you what I found inside this machine. And then we will try to save it. I just noticed the serial number is pretty low on this machine. It's an 80,000. Considering how many they made, that is a very low serial number. The lid is a bit stuck on this machine, and it's not too uncommon. When that happens, I like to pull from underneath. That often gets the lid off. Inside this machine we have the usual stuff: the floppy drive, hard drive, probably a 10 meg drive, and the usual floppy controller, hard drive controller, and a CGA card. But then we have something less common here. Down here on the motherboard we seem to have a problem. Check out U22. It looks like it has been drenched in battery juice. The strange thing here is that I can't see a battery. This card actually doesn't have a battery installed. So where did that battery juice come from? Let me pull that card out so we can have a closer look. Yes, this definitely looks like battery juice. This chip here has corroded legs, and same thing down here. There seems to have been a battery installed here at some point, and then it has leaked and found its way down to the ISA slot. So this ISA slot has green pins, and then it ended up in this area here. Let's have a look underneath these cards here and see how bad this is. This card is not installed with original IBM screws. We'll take a closer look at that card in a minute. But let's first check the motherboard and see how bad this is. The CGA card looks pretty normal and undamaged. The chips have dates from 1983, so probably the original card. The hard drive controller actually doesn't have a screw at all. Not even the wrong one. The hard drive controller looks fine too and undamaged. Dates, however, are from mid-1984. So this card has been replaced. That is 1 year off. The floppy controller is missing the screw too. The floppy controller looks fine too, and it has matching dates. There isn't much to say about these. These cards pretty much always work. I have never heard of a bad floppy controller in a 5160. The serial card is missing the screw too. Same thing here. Matching dates and 3 tantalums that are going to blow one day. Who knows, maybe today. The damage seems to be just in this area here and in this ISA slot. This is a 64 to 256K board, so that matches the low serial number. Dates on these soldered chips here are from around week 20 of 1983, so that's definitely a match. I checked underneath and both screws are missing for the hard drive and the floppy drive. So the hard drive is only held in place with one screw here. Hard drive is a Seagate, model number ST412. And on this side of the drive it has a matching date. Well, the floppy drive at least has both screws on this side. So someone has definitely been messing around with this machine and forgot to install some of the screws. This machine definitely needs a wash. So I'm gonna go for a complete disassembly. And as you know, speakers don't like soapy water, so I'll remove it. And now we can disconnect and pull that floppy drive out. Well, the case looks to be in really nice condition. It's very dusty, but that paint job still looks great. Never seen one of these. IBM Source Inspection. What's that all about? The floppy seems to be broken or missing something, because this piece here is all flimsy and loose. We'll check it later. Now, what have we got here? Hiding away underneath all those cables. Before we continue, I'd like to say thank you to PCBWay for sponsoring this video. I have been using their PCBs for years now. and I'm really happy with the level of service and the quality of these PCBs. This is just a few of the projects we have built on this channel. So head over to PCBWay.com and order some PCBs for your next project. Thank you PCBWay for supporting this channel. Hello little Varta. So here's our problem. I guess it was so badly corroded it fell off the card and presumably ended up here during shipping. Well, I hope it didn't leak anywhere else on the motherboard. We better check. Nasty little Varda, the destroyer of vintage computers. The motherboard is held in place with just 2 screws. One in the corner here and another one on the edge here. The rest is plastic clips, so now I can pull the motherboard out. I hate those clips though, they tend to get stuck. Underneath we have something interesting here. Check out these bodge wires here. Never seen these in a 5160. Some early mistakes, probably fixed on later revisions. I'll remove all of these annoying clips before we start working on the board. This machine is obviously untested. You can't just turn one of these on. They are pretty much guaranteed to go bang. Either one of the tantalums on the motherboard or a reefer inside the power supply. So let's have a look inside the power supply next. Well, here's something different for you. There's some kind of oily substance that seems to have come out of the power supply. And over here too. And then it seems to have moved in this direction here. And soaked the case here. So that's some really sticky dust. I can't seem to be able to get it on camera. I tried from different angles. But there is some kind of oil. Maybe you can see it on the Q-tip. So what the heck are we going to find inside here? Aside from the usual IBM bolts, this power supply also has a couple of security screws. And these are T15 with a tiny hole in the middle. Oh, maybe I should have used a Dremel. Maybe some other day. This thing here is disgusting. I keep having to clean my hands off that oily stuff, whatever it is. Okay, 2 more screws on this side apparently. There's a lot of screws for a power supply. Now, why is there oil inside? Well, there isn't. But we do have a couple of reefers. Well, this is very strange. I had a look inside here and I can't see any of that oil. The power supply is quite dusty inside. We do need to pull these 2 reefers out. So I might as well complete this assembly and wash both PCBs. For a moment I thought perhaps we had some leaky electrolytic caps, but I think I'm wrong. These are, by the way, 1/4 inch bolt head screws. The dusty fan here is a 12 volt Panaflow. I skipped ahead here a bit. This is not an easy power supply to work on. One of the screws is down in the corner here, so I had to use a much thinner tool to reach it. And the screws on this PCB were just about reachable. Other XT power supplies I have worked on have been much easier. So this one is some kind of special. Both IEC connectors are installed with rivets and then soldered directly to the board. So we would have to desolder all these cables just to get this PCB out. So I'm going to leave it like this and replace these 2 reefers and just wash everything like this. There are no signs of that oily stuff on this side of the PCB either. I just realized something here. Could that oily stuff be fresh battery juice? In that case, we're extremely lucky. If this machine had been left like this, it would have been pretty much destroyed quite soon actually. But I'm not sure, what do you guys think? Well, we found that damn Varda here. And check out this wet spot here. And this is where the card was installed. Look at this spot here. It kind of looks like it's coming from that card, doesn't it? Here's a close-up. This is where the card was installed. And underneath that card, we've got this oily stuff. Yeah, I think I'm right. I think this is fresh battery juice. Wow, that was a close call. Whatever it is, it has flown in this direction here. Perhaps you can see that the chassis is a bit glossy here. That is some of that oily stuff. I'm not going to neutralize the case, since that stuff looks fresh. But this battery juice here is old. So I'm going to add some white vinegar before I wash this board. This stuff is corrosive, so you can't leave it on for long. Just a few minutes. Strange thing is that it doesn't form any bubbles. At least not that I can see. Well, if it's not doing anything, I might as well clean it off right away with some IPA. I almost forgot the ISA slots. Only 4 or 5 of these pins are green. So I'm just going to apply some vinegar to the damaged pins. I'll wash that stuff off too in a minute. I am of course going to do a proper wash of the entire board in warm soapy water. But that is for later. It's difficult to see now because the board is wet from IPA. But several of these pins are corroded too. Well, as so often with battery damaged boards, it's slightly worse than it looks. So after a close inspection, 7 of these sockets are bad. And 6 of these sockets, these 3 and these 2 here. Then we've got these orange little buggers here. They are pretty much guaranteed to go bang if we turn the power on. So the next step is to remove all the tantalums and a whole bunch of these sockets here. But first, something hilarious before we start desoldering stuff. Since we're going to hack this board to take 640K of RAM directly on the motherboard, I checked if it had a socket for U84, and it did. And it also has a chip installed here. So first I thought, perhaps it's already been hacked. This is a period correct hack after all. So some of these boards were hacked back in the 80s. But this is not an LS158, this is a RAM chip. So someone was probably installing RAM chips in this bank here, and thought they should install one in this socket too. I'm gonna start by pulling all the chips from the damaged sockets. And these RAM chips are not gonna go back on the board, since we're going to do the 640K hack. So sneaky IBM actually designed these boards to take 640K, but they were selling them as 256K max, and without U84 and 1 jumper. Okay, I have marked all the sockets to be replaced, and all the tantalums. But we're not gonna get far with the desoldering gun quite yet. First we need to heat up the entire board. I use a regular cheap heat gun, and heat the board up for about a minute. This is going to make it a lot easier to desolder all the components, because these boards have a really thick ground plane, and it's almost impossible to get those tantalums off without preheating the board. I heat the board up so it's just about too hot to touch. I once took this too far when preheating a board, and components started to fall off the board. So you probably want to keep this to around 1 minute. And you can always heat the board up some more if it gets cold. In fact, I am gonna have to reheat this board several times to remove this much components. And all the sockets have bent legs. How extremely annoying. This is not going to be a quick fix. So I think I'm gonna remove all the components and skip ahead here. Otherwise I'm gonna bore you to death. Wow, that took some serious effort. I had to preheat the board about 10 times to desolder this many sockets and caps. And there is of course still solder in some of the pads. So the next step is to add some fresh solder to all the pads that still have old solder. With the new solder mixed in with the old solder, I preheat the board again and have a second go with the desoldering gun. Next up I'm going to unbend all the pins. I usually use this tip here, and it certainly works, but it does scratch up the board. So today I want to try out something new. I think this could be a better choice. Many of these pins are already unstuck, so I can just push on them and get them unbent. But if I feel any resistance at all, I stop and heat the pin first. Otherwise it's going to rip the pad off. Yes, my guess was right. It's much easier to unbend the pins with this tip here. I'll write on the screen what tip it is. Okay, so this one is stuck. So first I'm going to heat this pin. And then I'm going to bend it. Yeah, this is totally working. So I'm gonna skip ahead here until all the pins are unbent. Okay, that went pretty well. But I had to add some fresh solder to get some of the pins unbent. So I'm gonna have a second go with the desoldering gun. Okay, some of the components are starting to come off the board. But some of them are still stuck. Especially these sockets here. So the next step is to use the Rework station to heat up what's left of that solder and get all of these sockets unstuck. I don't use any force at all. I just very gently pry. The through holes are pretty clean from solder, so these sockets are coming off very easily. So it's pretty good that most 5160s didn't have a real-time clock. Some of these sockets are melting, but that doesn't matter, of course, since we are replacing them anyways. I think this one got damaged from heat, so I'll replace this socket too. I use different methods for removing components with a desoldering gun. Sometimes I wiggle, sometimes I just hold it still, or like in this case here, I kind of move it around very gently, not to scratch up the board, and sort of feel if the pin is loose before I push the trigger. The advantage of this method is that it doesn't scratch up the board, if you care about such things. Okay, so with the pin unbent, the desoldering gun is actually doing a much better job. The added fresh solder of course helps too, so I think this is the better method. I guess I'll be a bit more careful not to damage more sockets. This project is big enough as it is. Quite a few of these pads here are corroded from the battery juice. So we need to clean this mess up before we can install new fresh components. So I'm going to add some flux. For this I'm going to use a large flat tip and a tiny splash of solder. And then just let the flux do the job. And now we can clean up this area too with more flux. Some of these pads are quite stubborn. That is fixed with more flux. The pins on these two chips are pretty crusty too, so I'm gonna clean them with flux too. I'm not sure if this is strictly necessary, but I think these pins are going to continue to corrode unless we clean them and tin them. I hope these chips are still good, but if not, I think pretty much all of them are still available, at least on eBay. Okay, I think that looks pretty good. So the next step is to clean some of the excess solder with some solder wick, and of course more flux. This is enough to remove the solder from most of these pads. Some of them are going to be a bit more stubborn and require us to use the desoldering gun. Yeah, this was a much bigger project than I thought, but it often is when it comes to leaky batteries. Okay, I think we're done with the flux. And now to the not so fun part. Cleaning up the flux. I clean it right away while it's still warm, because it's much easier. I just take a Q-tip and then I twist it and twist that flux on the Q-tip. I definitely do not use IPA at this stage, because that is going to create an incredible mess. It's much better to use dry Q-tips when we have this much flux on the board. And then just twist the Q-tip. So we're almost scooping up that flux. Now it looks incredibly messy. But it only takes 5 minutes with this much flux. We are of course going to use some IPA later. And finally we are going to wash this board in soapy water. Okay, a couple of minutes later, most of the flux is gone. But the board is of course still sticky. But before I clean the stickiness off, I'm just gonna grab the desoldering gun and clear out the remaining through holes. I don't understand why this board is so stubborn. I have fixed quite a few of these boards, but this board seems to suck up more heat. So now I wonder if these early boards have a thicker ground plane. I don't know, but something is going on here. I didn't have much luck with the desoldering gun, so I'm gonna add flux on this side of the board too. I'm gonna try with the solder wick. Okay, let's see if this works. So often flux does the trick. And then the same procedure to clean up the flux on this side of the board too. Okay, it's early the next morning, and unfortunately I forgot to clean up all the flux. So it has now gone cold and pretty difficult to clean up. But this is an easy fix. Normally I would just use the rework station and heat the flux up and make it easy to remove again. But with this much flux, I'm going to use the heat gun instead. And just heat that flux up. About 30 seconds should be enough. And now that the flux is nice and toasty, it's easy to remove again. With still some flux left in the through holes, it's kind of hard to see if they're all cleaned up from old solder. So I use my smallest desoldering needle and check and make sure they're all cleaned up before we can start installing components. One way to deal with stubborn through holes is to preheat the board and then heat up the desoldering needle with a large tip and then push that old solder out. It's not a quick method, but if it's a really stubborn pin, this can sometimes be a good method. These are made out of stainless steel, so the solder doesn't stick to the needle. When nothing else works, I go pretty extreme with the desoldering gun and then also add some heat with a large tip. This is pretty much guaranteed to work. Okay, all the through holes are checked and cleaned up, so now we can clean that flux off. We'll add some IPA and a Q-tip. I don't go for perfection since I'm going to wash this board. Yeah, that's good enough for now. At this stage I like to wash the board, but unfortunately I only have time to wash this board once this week because it takes many hours to dry. So we're gonna move on and install some sockets. I like to solder 2 of the pins roughly in the middle of the socket and then make sure they are installed straight and flush to the board before I solder the remaining pins. So if you're on the market for a 5160, this is something you should consider. I guess you could ask the seller to have a look inside and check if it has an expansion board with a Varda battery. I still think you should buy it and repair it, but the price should be much lower. Okay, all sockets are in. Let's install some tantalums. These are 10 microfarad 16 volt caps. Make sure to check the polarity, otherwise they're gonna go bang. Polarity is very clearly marked on this board. And so are these caps. There are quite a few unused pads for caps on this board, so make sure not to install them in the wrong position. This is the most common fault on 5160s. I don't even bother turning these machines on before I have replaced all the tantalums. Some of these boards have 3-legged caps, but they also have pads for 2-legged caps, so you can use these instead. I bend the leads when I install components to prevent them from falling out, but when both leads are soldered, I bend them back up again. This is going to make life much easier for the next person who works on this board. You are going to need 16 of these, by the way, if you're ordering parts for your projects. To finish this board off, we need to clear out the solder in these pads here that are marked E2. I'm gonna add some fresh solder first, and then use the desoldering gun to remove all that solder. And now we can install some pin headers and a jumper. This jumper is for the 640K hack. You could be lazy and just bridge these two pads, but this is the proper way to do this. We better pull that RAM chip out, because it doesn't belong here. And we're gonna need that socket. Your board may not even have a socket at U84. In that case you need to install one. So what do you guys think? This chip is probably toast. And we're in luck. I found an LS158 in my stash. So let's install it in U84. And now this board can take 640K of RAM instead of the original 64 to 256. But then we need more RAM, of course. So I'm gonna remove 64 by 1K chips from bank 0 and bank 1. If the board is maxed out at 256, bank 2 and 3 should have 64K by 1 chips installed. So I'm gonna clean the legs of the original chips with a scratchy pen and install them back on the board. Since we had some corrosion on the pins of these chips, I'm gonna add some DeoxIT in these sockets before I put these chips back in. And hopefully these chips are still okay. To reach 640K, we need to install 256K by 1 chips in bank 0 and bank 1. These are Oki M41256. Okay, we should now have 640K of RAM on board. Switch 3 and 4 should be set to off to enable all 4 banks of RAM. I'm gonna apply some DeoxIT in the ISA slot that had some minor corrosion. Let's do some overclocking. That means removing U1. Unfortunately, it's not in a socket. And I'm gonna use my new method to unbend all the pins with this new tip and adding some fresh solder as I go. Yeah, this method is great. I'm glad I decided to buy and test that tip. Okay, the pins for the 8284 are still stuck in old solder on this side. But we can't use the rework station on this side of the board because we're too close to this ISA slot. So I preheated the board, and now I'm going to heat all the pads from this side of the board instead. If you're lucky, U1 is going to be in a socket on your board already. In this case, unfortunately not. As I heat the pads up, I'm pushing gently on the pins until it gets unstuck and falls out. Yep, it's coming off now. So I'm gonna use the screwdriver and very gently pull that chip off from the other side of the board. Still not using any force because I don't want to damage any of the pads. It seems to be stuck in this one pad here. So instead of using more heat while the board is still toasty, I'm gonna use the desoldering gun to clear out that hole. Okay, here's our chip, and the board is ready for a socket. Okay, socket installed. I'll go ahead and wash the board off camera now, and I'll see you on the other side when all the parts are cleaned and dry. I almost forgot about the expansion card. Well, I can't imagine why anyone would need more than 640K, but let's try to save it anyways. So here's where the battery was installed, and the battery juice has found its way underneath the solder mask. So that is gonna have to come off so we can clean it and stop the board from further corrosion. This socket here is definitely shot, but let's hope this chip is okay. Don't know what that chip is, but it may not be available anymore. This socket here is a goner too, for sure. And the same thing with the first row of RAM chips here. Those sockets are dead. From my experience, switches don't like battery juice. So that switch block is quite possibly dead too. But at least it's easy to replace. So I'm just gonna take note of the position of these switches, in case we can't find a manual for this card. On this side of the PCB it just says Made in Taiwan, ROC. On this side of the card we have a sticker that says PC-11C and then a bunch of numbers. I checked with Google, but I couldn't find anything. So if you know anything about this card, please share. The edge connector looks pretty bad too, but I think this is fixable. Let's start by pulling some of these chips. Oh, that is crusty. Well, who knows, it might still work, if we're lucky. How about that crusty sound? Same thing here, let's just hope for the best. RAM chips are easy to replace, so this shouldn't be a problem. Well, 4 of these sockets actually look okay. So the battery juice went down this way and then decided to leave these sockets alone and went down this way instead. So I'll start by removing these 4 sockets. The large socket here and the socket down here. And we will be able to have a better look at the PCB underneath the sockets here. Okay, I did all that off camera, not to repeat myself too much in this video. So these 5 sockets are now gone. The large socket up here. And U32 down here. So the next step is to clean this mess up here. Because if we don't remove this, it's gonna continue to corrode and get worse. This is gonna get noisy, so I may skip ahead here. I'm basically going to use the Dremel with the soft rubber tip and clean this PCB until I get all the corrosion off. Okay, so the soft rubber tip is actually not enough. This corrosion is too bad. In that case, let's try with the engraving pen. Yeah, this is much better. This is totally working. So we need to get enough of this stuff off to allow the flux to do its magic in the next stage. Luckily, I think this is just one large ground plane. Okay, I think that's enough so we can finish this with a soft rubber tip. So the thing with this tip here is that it removes the solder mask without damaging the trace underneath. Okay, I think that's enough. Now let's see if the flux will do the rest of the job. And again, I'll use the large flat tip with some solder. I think we're gonna have to use a lot more solder. Let's try with more flux. No, that copper is so badly damaged. It won't take any solder. Okay, this may not be as bad as it looks actually. So this large pad here is connected to ground. And as far as I can tell, the only thing missing here is the battery here. And by the looks of it, this via here is not grounded anymore. So I think we only need to connect this via here to ground and the battery. And at least this part here should be fixed. I installed new sockets for the RAM and these 2 chips here. Let's see if that green stuff comes off the edge connector. Well, sort of. There's still some left. Let's try with the Dremel. Yeah, that totally works. This side is slightly worse. But with the Dremel, this is a quick fix. It looks as good as new. Okay, the next step is to wash this board. So I'll skip ahead here. Okay, it's the next day again. Everything has been washed in warm soapy water. So every single piece of this machine is now super clean. Now let's finalize this project. We'll start with the power supply and replace those 2 reefers. And these guys are 0.1 microfarad X2 caps. They are slightly smaller in size than the original Rifa, but luckily this PCB has 2 lead spacings. Oh, I almost forgot the disclaimer. Please don't mess around inside power supplies. They may contain high voltages, even with the cord unplugged. Watch my videos instead. This is much safer. Silly jokes aside, some of the caps inside power supplies may actually be charged with high voltages. So if you don't discharge them, you're gonna get zapped with mains. Well, I mentioned earlier that this power supply is a bit tricky to work on. And I wasn't joking. It's even more difficult to reassemble. But at least now it's really clean. There are no bulging caps or signs of leakage in this power supply. In fact, aside from exploding Rifas, I have yet to see one of these power supplies go bad. Even that brushless Panaflow looks brand new. Okay, next up we have the floppy drive. And it seems to be missing one of these thingies. I think there should be one installed on this side too. Or maybe it should be one long piece and it's broken off. It's kind of hard to tell. If I can't find one, I can probably make one. And if you know someone who sells these, then please share. But for now, I'm gonna put this aside and use a different floppy drive, so we can finish this video. The RAM expansion card cleaned up surprisingly well. It now actually looks pretty decent. Well, except for this large brown spot, of course. But I don't want to put more effort into this card until I know it works. So let's focus on testing it. And if it works, I'll put some more effort into making it look nicer. So first we need to clean all the pins on the chips we removed. I'll use my abrasive pen for this. It tends to get the job done good enough. If these chips work, I will tin all the pins to prevent them from corroding again. And since those chips had some corrosion on the legs, I'm gonna use DeoxIT in all the sockets. Oh, that's interesting. Let me check. As you can see, this chip here is 2 pins smaller than the socket. So I had to go back and check earlier in this video. There was indeed a smaller socket here, but there were pads for this larger socket. Yeah, even the silk screen showed a larger socket. So I'm gonna leave it like this. It doesn't make any difference whatsoever. So I'll just move on, putting DeoxIT in all the sockets and reinstalling all the chips we have removed. The chips in bank 1 here are 41256s, just like the one we installed in bank 0 and bank 1 on the motherboard. But bank 2 and 3 here have 4164 chips instead. So you can do the math how much RAM this card has. But if I'm not mistaken, I think we're going to reach 1 meg of total RAM in this machine. If this card actually works. And if the motherboard works. And if the 640K hack works too. That is a lot of ifs. Now what the hell are we gonna do with 1 meg of RAM in an XT? Is there like a fun game that requires that much RAM? Let me know if you know. As for the battery here, I'm just gonna go for an ugly bodge for now. And then I'll make it pretty, if we can make this card work. I'll start by adding some solder to these pads. There's nothing left of this pad here, so I'm gonna add a blob of solder to ground up here instead. And also to this via here. And then I'm going to solder a diode to ground here and to this via. So this should replace that large ground plane. And then I'm going to grab a battery holder and solder it to this pad here and the big old blob on the diode here, so we can solder the other wire from the battery. It doesn't get uglier than this, but for a test this is perfect. This battery holder here takes 2 CR2032s, and they are connected in series. So this should give us about 6 volts. And the diode here is to prevent the card from charging these batteries, because the Vada battery is rechargeable, but these are not. I'll use some double-sided tape to hold the battery in place. I'm also going to use some tape so we don't short that diode to something. Yeah, I think this is good enough for a test. The board looks amazing after the wash. I did not expect this when I first opened the lid on this machine. This board is now pretty much mint. There are no signs of leaky batteries anywhere on this board now. And being freshly washed, it looks extremely clean too, of course. But before we reinstall it in the machine, let's do some overclocking. So first we need a CPU that will go faster than 4.77 MHz. So we need to remove this 8088. In this machine it's manufactured by AMD. There is a pretty interesting story behind why some of these machines have CPUs from AMD, but we don't have time for it in this video. Instead we're gonna press on and install a V20 that can go up to 10 MHz. To speed up the clock, we're going to use a PC Sprint. This is one of many projects we have built on this channel, with the help of the sponsor of this video, PCBWay. So if you need one of these, check out the link below, where you will find the Gerbers, and then you can just upload them to PCBWay.com and order a set of PCBs. For this machine here, I'm going to go with a 22.11 MHz crystal, because this machine doesn't have a turbo switch yet. And if we use any faster crystals, we won't be able to use a floppy drive without switching to a slower speed with the turbo switch. With this jumper here, this board is set to constant turbo mode. So this should give this machine a pretty good boost. And now to my favorite part of any project, the reassembly. The chassis looks great. Whatever that nasty goo was, it didn't have time to damage the chassis. I'll start by reinstalling all those plastic clips. And now we can reinstall the motherboard into the chassis. Now let's install that borrowed floppy drive. I had a look inside, and this drive has a much longer metal rod instead of 2 small plastic rods. So I guess that's what I'm trying to find for the other drive too. I placed a drop of machine oil into the stepper and did a low-level format in another machine. So this is a working drive. So first we have the serial card, and then I'm going to leave one of the slots unused and install a floppy controller in this slot here to make some room for cable management in between here. Next we have the CGA card, and finally our battery bombed expansion card. I almost forgot the speaker for those annoying beep sounds. Okay, all bets are off. Let's see if this machine works. Okay, the fan spins up in the power supply. Hard drive spins up. But we're getting nothing on the screen. Well, that sucks. So let's start removing stuff. We'll start with the serial card. We'll try again. No, still doesn't post. So let's remove that RAM expansion card. And we'll try again. Oh! It posts! Okay, so that RAM expansion card is definitely not working. Now let's see if that hack worked on the motherboard. Yeah, we've passed 256K of RAM, 512 and 640K. Awesome. So the motherboard now has 640K of RAM, but this expansion card unfortunately is still bad. Well, I'm not quite ready to give up on the expansion card. It's also a pretty good match for another planned video, so we'll give it another go. If you're watching this in the future, there will be a link on the screen to that video shortly. If you're watching this fresh, hit the bell icon below and set it to all. This 5160 was manufactured in the first year of production. If you haven't watched my video restoring the 5160 from the last year of production, now is a good time to catch up and compare the two. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. A special thanks this week to Niels for the generous donation on Ko-fi. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching, I'll see you next week.